Okay, so now we're going to be talking about something called dplyr, which you will see written out a ton, but it's dplyr, D-P-L-Y-R. Plyr is something you use as a tool to, I don't know, it's a tool. And so we're going to use this called dplyr, technically is what it would stand for. And dplyr is a really foundational tool of the tidyverse. As with ggplot, dplyr is one of the things that gets people most excited. It will help you answer a lot of the questions you have with your data, get your data into the right format, change your data into the format you want, create metrics. It's everything that you want to do. And if you actually look at basically what actual data scientists who work in industries say that their job is, about 50% of it is data wrangling, which is what we're going to be working on today. So if you look at this behind me, we can see we've got dplyr, wrangling data. And so wrangling tends to be a word that we talk about with animals, but you will hear this called data wrangling, you'll hear it called data manipulation, but that kind of has a bad connotation, so I don't like to use that term. There's a lot of different ways to call this, but basically we're getting the data into the format that we want. Again, this is like 50% of what a data scientist's job is, whether that's data wrangling with dplyr or something like SQL, structured querying language, to get all of this data that we have and make it what we want it. We're not we're not necessarily changing the data. We're not, oh, I don't like that this is a 1, I'm going to change it to a 0. We're not doing that. We're basing things on the data and creating new variables, for instance. So the first thing that we need to talk about today is data frames, basically. So I'm going to zoom a little bit out of my way. So let me move this here. Sorry, moving everything around and sharing the screen. So this is just the lesson plan for today, which everyone has access to. Why is this here? I want to move this. There we go. So everyone has access to this. It's on our course website, but there's just a few little overview things that I want to cover before we actually get into R. A lot of this is just stuff that you pick up on and I find very boring as a learner to learn about, or at least I did when I was a beginning learner. So I'm going to cover it very quickly. And again, it's just something you pick up while you're learning R, and you can learn more about it in the textbook, for instance, and as you go. That's very much my learning style. So in R, we've got multiple different data types. I'm not going to go too deep, but we have something called logical, which would be like a true false data type where you can only have true or false or null. We have integers and doubles, which are both numeric data types. Double tends to be longer, integer tends to be whole numbers. Then we have character, which would be anything that's a string. And then other things that you will 99% of the time never use, which would be complex or raw data types. Don't really need to worry about that. But those kind of are what we've been looking at with our column data types. So in the previous labs, I've asked, like, what kind of data is this? If it's a quantitative or continuous data, it's going to be an integer or a double. If it's a character level data, it's going to be, say, character or factor, which is a more complex type of character that we will talk about more like in week 8 or something like that. Now, these data types, when we're talking about data science, when we're talking about data wrangling, we're 99% of the time talking about data frames or tuples. A data frame is a type of data where you have rows and columns. Rows are observations, so individual observations, and then columns are specific attributes of that data. We're going to go a lot deeper to this when we start talking about tidy data and how to get your data tidy. You see the word tidy as part of the tidyverse, and that's a fundamental part of the, I wouldn't say pedagogy, but maybe epistemology of the tidyverse. But what you need to know is basically you have rows, you have columns. This is kind of all intuitive, and I think everyone's picked up on this as I've just thrown it at you and you've seen it, and it's something like you would see in Excel or in a database table. Now, we have data frames, and in R, you can make data frames. However, there's also something called a tibble. Tibble is a table, but this was created by Hadley Wickham. You'll recognize that name because I've mentioned him before, and Hadley Wickham is New Zealander. So as a Kiwi, he says tibble instead of table. And so he created this new version of a data frame based on data frames. However, with Tibbles, you are able to browse your data a lot more efficiently, and there's some things in the back end that make it more efficient. For me, it's basically that you can create data frames or Tibbles easier using things like Tribble. We'll probably cover this eventually, like creating your own data frame from scratch, but usually you're going to be importing data if you're working with large data sets. So like in practicality, I don't even remember on a day-to-day basis how to do it because I do it so rarely. So like I have to look up the code every time I want to do it. So you can create data frames easier, or you can create Tibbles. From now on, every time I say data frame or Tibble, I mean Tibble, because it's the actual thing we're going to be working with. But the really great thing is you can explore them easier, and they, you may have noticed if you printed a data frame before out into your console, it was really long. Sometimes it printed out the entire data frame, so you have to like scroll through 1,000 rows of data. Tibbles won't do that. They're going to, by default, only print out like the head version of it. So they'll only print out, I think, 10 or 15 rows. And they'll only print out however many columns fit in your console. And then if you want more columns, you know, you have to do other operations to be able to see them, like view. So Tibble is super useful. That's what we're going to be using. If you want to know more about the differences, just create a data frame, kit a Tibble, try viewing them, see how different they act. But Tibble is basically an easier data frame. That's about it. And then dplyr, as I mentioned earlier, is what we're going to be working with today. So there's a bunch of stuff here. We're going to cover all of this, but this is like notes for you to be able to look back on and read. And, you know, after you go through the chapter, or you're like, oh, how do I get a row again? This is what you can look back on. So this is why it's on the website. And so now we can actually start coding in R. So I'm going to move this out of the way and start with dplyr. Can everyone see my R script or my R Markdown document? Great. I figured, but it's good to double check. So I'm going to create a new code chunk, and I'm going to load the tidyverse like we always do every class. Tidyverse. Oh, it's because I spelled library wrong. There we go. I was looking for an autocomplete and it wasn't autocompleting, if anybody was wondering why. I was like, what's going on? And then I will load the Palmer Penguins data set again. So this is the data set we looked at last week, and we're just going to continue on with penguins because they're adorable. So I'm going to say data penguins. I think that's it. So let me run this chunk, make sure everything loads. We've got penguins up here in the corner. And one quick aside is that I saw this on Reddit the other day, and it reminded me of our class. So I'm going to play it for just a second. We don't need volume, but this is penguins being weighed. And I was like, that's perfect. So this is very loud, but that is what we will be looking at today. Basically, penguins who were weighed and measured in various instances. And we already know a little bit about this because we worked with it last week. So the first thing we're going to do is explore our penguins. So we know a few different commands to explore our data frame or our Tibble. Can anyone tell me any of those commands that we learned? No one remembers how to
Head, tail.
Yeah, thank you.
Summary.
Penguin, yes. And we got someone in the chat too. Yep, structure, summary, great. So we got head, we have tail, we have structure. Actually didn't teach you structure, so good job, Jinru. Summary. Okay, so these are all great. You know, we can see now as a Tibble, it's going to print it out quite nicely. Like I mentioned, it's only printing out the top 6. Well, that's because we did head, but it'll still print it out nicely because it's got the name, the data type, etc. Structure looks pretty nice, but I'm going to show you a better version of structure in a second. Summary brings all of the different data frames with all the summary data, but what my favorite is, and that we can actually do now because we have the tidyverse loaded. Last time I taught you we didn't have it loaded. We're going to do glimpse. So what glimpse does is it tells us how many rows we have, how many columns we have. Each column or each variable that we have what data type it is, and then it gives us a sample output of what that data looks like, and it'll go as long as your console is. So if I make this smaller, you can see it now wraps ugly, but when I print this, it'll only print that long. So Glimpse is great. It tells us a little bit about each of the variables. We have species, which has 3 different types of species. Remember, we've got Gentoo, Chinstrap, and Adelie. Then we've got bill length, bill depth, flipper length, body mass. You remember this all from last week. So now what I want to show you all is how we can actually, instead of visualizing this, really work with this in sort of a table-like format. So I'm going to make another head and say selecting columns. So the first thing we will learn to do is say, I don't want all these columns, I only want some of them. So we can say select penguins, and I'm just going to copy and paste this a few times because I'm going to show you a few different versions of the select function. So the select function comes from dplyr, and we're saying select the penguins data frame, or tibble, and then I can just now start writing which columns I want. So I can say I want species and body mass, and I should, no, okay. Later it will let me autofill these, and I'll show you why. So if I run that, now I can get the entire data frame, but I'm only getting the columns that I'm requesting. Another way I can do this is by saying I want this column through this column. So I don't want to write every single column. I'm sure many of you have worked with data that's like 100 columns. You don't want to write them all out. So you can instead say I want species and I want bill length through, and that's how we use that colon. We say through, let's say sex. So now we're going to get bill length through sex. Those are the only columns we should get now. Yeah, and you can see we've got species, bill length through sex. So that's based on the positions of those variables as is. We can also say I want everything but remove this column. So let's say I want everything but year. I just hate the year variable. I want it removed. Hold on, that's not efficient. Let me do 2 of them so you can see better. Let's remove island because that's right here and we'll be able to tell better. So I can say, I want this data frame, but remove year and remove island. So now we don't have island and we don't have year, which was at the end. And we can do the same thing where we can say this through that using the minus remove sort of symbol. So I can say minus species through island. So let's remove those first 3 columns from the penguins data set. Let's run that. And now I lose all of that kind of meta information about what penguins and island was there. Any questions so far? Okay. I'm going to keep going. I'm probably going to go fast, but if you have any questions, please interrupt me. So let's do some more advanced selecting functions with tidy selection. I don't know if you guys can see that one, but it's incredibly annoying. I don't know what's going on. Just going to retype that part. I have something funny going on with my R, and I haven't figured out what it is, but that works. Okay. So more advanced selecting function with tidy selection. So tidy selection is something you don't really need to know about that much about, but we can do kind of cooler things now. So instead of saying this column through this column, what if I want to select everything that ends in millimeters? So I want all the measurements in length instead of weight. So I can say select from penguins. I can say ends with, so you can see this is a function from dplyr. I can say ends with millimeter. So now tidy select is very smart, and it's going to look at all the columns names and see which ones end with millimeter, and I'm able to gather all of those at once. I can also select from penguins starts with, and let's say I want everything about the bill. So I can say starts with bill. So hopefully this kind of gives you an idea that you should also have your variables named efficiently. So if you have something like measures, they should always be either at the beginning or at the end in whatever unit it is. If you have something about the bill versus the flipper, keep your naming consistent so that you're able to do things like this and tidy select them, which is super efficient. Tidy select penguins, and then we can even say contains. I think it's contains. Hold on, let me just triple check. Yes. If I did a parentheses, that would help. So I can say contains length. So if I run that, now we'll get everything that within the variable name, we have length. Super efficient, like I said. So now it's able to get something from the inside of the variable name. And what's super cool is I can also say, and I want species. So we have the data frame name and then whatever columns we want. If I want that plus species, there we go. And it's going to go in the order that I call them. So first it'll say anything that comes with length, and then it'll put species, whereas species originally was like over here. It moved them. This is really efficient, like I said. There's other things you can do with like regular expressions. If you know what that is, we will get a little bit more into regular expressions when we start talking about strings and string R and like, I don't know, week 9, something like that coming up eventually. But this gives you a good idea about what tidy select can do. And you can use this in a lot of different ways, and we'll use it even more in advanced dplyr in 2 weeks. So now let's talk about filtering rows. So I like to think about the difference between filter and select, as selecting is removing or adding columns. Filtering is focused on the rows. So which rows are being displayed. So if I want to get rid of some rows, let's say I only want to look at penguins from Dream Island. What I can do is I can say filter penguins island equals, and I think it's Dream. So let's double check that. Yes. So now I only have the penguins from this one island. And you can tell the difference because now if I print out penguins just by itself, you can see I had 334 rows. Right here it says 334 by 8. Here, I now only have 124 rows. This is pretty cool. Now, many of you may be like, why do you have 2 equal signs? This is something that a lot of people are going to struggle with. It's just a natural part of learning about the difference between evaluation versus assignment. So I'm going to put a comment here. This equals assignment. This equals evaluation. You'll see more on assignment in a little bit. Basically, it's saying, put this into something new. Whereas this is saying, is this that? So is island Dream? There are other types of signs we can use. All of those are listed on the website. There's a lot of them. We can do something like filter penguins. Year is less than or equal to 2008. You can see we also eliminated rows. Only 2007 and 2008 are going to show up now. There's a lot of different little symbols you can do. You can do filter penguins. Year is not equal to. So anytime there's an explanation point, I know for some of you this is like review, but for others this is kind of new. The explanation point, it means not. So is not 2009. That should give us the exact same data frame we just had here because I already know that there's only 2007, 2008, and 2009. So let's see if I run that, I should also get 214 rows. There's a lot of different things. Like I said, all of those functions are on the website. Yeah. I can also do multiple conditions. So if I
have a question real quick.
Yes.
You wouldn't be able to do this with the base package?
So these symbols are base R. So you would be able to use these. However, if I was doing, let me see if I can write it off the top of my head. If I was trying to filter based on that, I would have to do, let's see, penguins. Everyone who doesn't know what I'm typing, just, you can kind of ignore it. Let's see, the rows or what I would want to edit. So then I would want to say penguins. Oh man, I'm so bad at base R. penguin, something like this. It would be like penguins year equals 2008, something like that, and then comma. Okay, so that did work. So it's just a lot less efficient, especially when we start stringing different commands together. So let's say I wanted to select specific columns and specific years at the same time. You start getting really complicated and it's hard to read. And that's one of the best things about dplyr is it's easy to read. So if you send it to your coworker, they're generally going to be able to pick up on what the heck you're trying to do. Once this gets too long, that's one of the big disadvantages of base R. But yeah, you can do something like that.
What did you say the exclamation equal sign meant?
So this means is not.
Okay, thank you.
So the little equal sign is, and then anything with the exclamation point in front of it is going to say is not. So I can show you another example of this. I'm going to jump ahead a tiny bit, but if I wanted to filter penguins, and then if I wanted to see only things that were NA and R means null or missing. If I wanted to say sex equals NA, this is not going to work. I would actually need to do is NA sex. Don't ask me why. It took me a long time to like really kind of remember this. So now I'm only looking at ones where the sex is NA. But if I wanted to see the opposite of that, if I wanted to filter out the NAs, I would have to do is not NA. And so that's where you put the exclamation point in front of it. So there are certain kind of commands that are a little bit different, but you're able to build on them. So now I filtered out everything with a missing sex. So I have 323 instead of, I think 340 something was the original. Whatever 323 plus these 11 is. So that's how you can look up missing data. Oftentimes you may want to remove the missing data, or you just want to look at the missing data and remedy it. There's many kind of reasons you would want to do that. But what if I wanted to, missing data? What if I wanted to now have multiple conditions? One way you could do it is kind of, oh, I didn't want to add a new chunk. One way you could do it is where it kind of works like select, where you can just add things with commas. If you add more conditions with the comma, they're just going to be basically look at this and this. So I could say filter penguins, where the island is equal to dream. Just a reminder, anytime you're looking at specific characters, they are case sensitive. So that's why I have to make sure I have a capital there, or else nothing's going to be selected. And then let's say I only want to look at Gen 2 penguins. So I can just say comma origin. Oh, no, it's not origin. It's species equals Gen 2. I have something wrong somewhere. So now's a great time to go into something that's planned pretty soon, which is how do I know what options I have? This is also going to be like more advanced than what we're already doing, but I can say count penguins. This is the way that I choose to see the different type of species. So I can say count from penguins species, and I can see the exact types of penguins. So we have Gen 2. That should be fine. Gen 2 species. And then, oh, I know why. Okay. It's because there's no Gen 2 penguins on the island of Dream. And that's something like you will know how to solve that issue and figure that out later, but I don't want to jump too far ahead. So I know there's Gen 2 penguins on the island of Bisco. So now if I say island Bisco species Gen 2, I'm only going to see Gen 2 penguins on Bisco Island. And I can just string that together with a comma, which would be the same as saying and. So if I wanted to do this, if I wanted to make it more explicit, I could put parentheses around these. But at the end of the day, these are all saying the same thing. This is also going to give me the same result where I can say island equals Bisco, species equals Gen 2. So that is the same as, if I put a comma and take away the parentheses, it's whatever you find easiest to read. And you can choose different things. I could do something a little bit more advanced though, and I could say like, I could have an or condition. So what if I wanted to look at Bisco penguins or Gentoo penguins? Maybe Gentoo are on more than one island. I actually don't remember. I would use this vertical bar. In some languages, that's a pipe. I don't remember what it's called besides vertical bar. Any programmers here can fill that in. But the vertical bar is above the enter on your keyboard if you have a standard American keyboard. And that means or. So if I run that, now you can see I have other penguins that are on Bisco that aren't Gentoo. But then if I scroll down, which I could say, I don't want to get ahead of, there's also Gentoo penguins here. Finally, if we're saying I want species equals Gentoo or Adelie. Adelie. If I want this penguin or this penguin, there's also one more way we can do this, and this is actually quite, it'll come up a lot. So this is why I'm teaching you. It might seem more advanced though. So if I want two conditions from the same variable for species, what I can actually do is filter penguins and then say species, the variable I'm pulling from, in. So this looks complicated. It's a %, in, %. And then I can say, here I would say Adelie, spelled it right, Adelie, comma, Gentoo. And closing parentheses. So what this is saying, if you remember what that C stood for, C basically means combine, put this into a vector. Species can be either Adelie or Gentoo, and that's what the in says. So Adelie or Gentoo in species. It looks complicated, but it's actually quite simple, and you're going to find that that comes up a lot where you want to do like this or that from one column, and so that's why I'm teaching you that one.
So does that do the same thing as the line above it with the bar?
Yes, so these are equivalent.
Okay.
There might be instances where you have like 5 of these that you want to pull. So maybe you have like 10 total types of penguins. You only want to pull 5 of them. This gets really old really quick. And once you have so many or conditions, it can get, I don't know if it gets less efficient, but it's like harder to read. And again, we want data science to be like open, reproducible. We want to be able to read it more. So having everything in a single C vector would make it easier. Also, one other thing I can do is I can say penguins I like, and I can make a vector like this and say so I can save this kind of externally and pull out those penguins like that. So if I say penguins I like, filter penguins I like, it'll only bring me the Adelie and the Gentoo. So there's different reasons why you would want to use that, but it can be very efficient, or maybe you've determined those somewhere else and you're just pulling in that vector. Anyways. Finally, I want to show you a kind of more complicated version of filter. Let's say I want Gentoo penguins from Bisco or Adelie penguins from Dream. It's kind of a complicated thing. I want these specific penguins from this one island or these specific penguins from this other island. So that would look like penguins. And then I would say here I would actually need parentheses because I want to determine what's selected first. So here I would say island equals Bisco, comma, or and, let's do and to be more clear. Species equals Gentoo. Outside of the parentheses now I can say or, and I'm going to break the line here just so it's easier to read. That's what's actually kind of great about R is it's not space dependent, so I can make things a little bit cleaner looking. So or island equals Dream and species equals Adelie. So now I'm saying I want this combination or this combination. So now I'll only have Adelie Dream penguins and Bisco Gentoo penguins. kind of more advanced, but you can start seeing how the logic of a filter statement could work. So we're going to move on now to pipes. Some of you, this will be very new. So if I wanted to do a filter and a select statement, I alluded to this earlier, it can get kind of messy. So one way I could do a filter and a select statement would be saying filter select. So select from penguins, let's say, I don't know, species, sex, year. And then filter that by saying, let's just copy one of these, island equals Bisco. Well, if I run this right now, it's not going to work because I'm selecting or I'm filtering based on something I didn't select. So let me add island in here. Penguins. So this is one where I could string multiple things together, and I can tell you right now, this is not great. And that's because you're like, okay, what am I doing here? What am I doing here? It might come back to the thing that I keep harping on, which is readability. This can get really confusing really fast, especially if you have more than just two things. Another thing you could do would be something like Bisco penguins and create intermediary objects. So I could say select from penguins, species, sex, year, island. And now I can, that's going to happen a lot, I feel like. Now from Bisco penguins, I can filter island equals Bisco. And then maybe save that as another object. So what this would be doing was saying select from penguins, these columns, save that as an intermediary object. And then from the intermediary object now filters the island equals Bisco. Some of you might already be catching on that this is super inefficient, partially because of space. If you're saving multiple intermediary objects, it's just not great. So one of the best things you can do, and this is something that we're going to really use a lot in class, and so y'all catch on, is using something called a pipe. What a pipe does is basically it takes something that goes in and puts it through to the next object. So if you're thinking Mario's going to go through the pipe and come out the other side. In practice, what this looks like is I could start with the penguins data frame. So I'm going to take penguins and I'm going to push it into the next thing. So a pipe looks like this. %, greater than, %. I hate that. And so what you can do instead of typing those out by hand, so instead of saying %, greater than, %, like that would just take me forever to type so many times. It's Control-Shift-M. So I'm going to write here, I'm going to copy and paste it actually. So if you're on a PC, it's Control-Shift-M, or if you're on a Mac, it's Command-Shift-M. So hopefully everyone can try running that. I do that so naturally that I probably won't type it out by hand a lot. So that's what a pipe is. We're going to take penguins, we're going to pipe it into a select function. So I can type that now and say select. You'll notice R is super used to pipes, and so it will automatically indent whatever you have next. So I'm going to pipe penguins into a select function. What automatically happens with piping is that whatever's last is going to be the first argument in the next function. So before we would write, let me scroll up to select, we would write select penguins. Penguins select by default wants the first thing to be the data frame. By doing this, we're already providing the data frame. So we don't have to write penguins here anymore, which is nice. We will already be fulfilling that first argument. And then the next arguments are what columns do you want to select? So I can write, let's just paste these ones. Species, sex, year, island. So again, I don't have to write penguins here because I already have it here. And I'm going to pipe it into the next argument. And let me run that to show you that it's going to be the exact same as doing this argument here. Select penguins. But the great thing is now I can add another pipe. And so I can say from Penguin's data frame, pipe that into a select function, only get these columns, and then let's now add another argument. So I'm going to say filter, and then now I can say island equals Bisco. So you can see every time I did my control enter or I clicked run, it's going to do this entire part where there's pipes. So from this, whether I click run from this first part or from this last part, it notices that everything's strung together with a pipe, and it's going to run this entire thing as if I highlighted it. So it first took the Penguin's data frame, that entire bit data frame, which actually I can show you by just highlighting that. So it took this, and then it selected the columns we wanted, and then it filtered those columns. So you notice we have 4 columns now, and we have 344 rows, and now it only has 168 rows there now. So we squeezed it tighter, and then we made it shorter. Pipes are super important, and we will keep working with them. But you do have to know that these are order specific. So because things happen in a very sequential order, if I don't put island here, if I don't select the column item, it's going to give me an error because it's going to say object island not found because there's no longer an island column. So let me put that back. What I could do is I could first filter, then select not that column. There's a lot of options, but the important thing is that ordering is important. I can also now assign this a new name, like I could call it Bisco Penguins, for instance. Great question, General. Let me cover that in just a second. So we've got, now I can assign this to Bisco Penguins, and this is now a delimited data frame that I just created. You can see how this would be super useful. So the difference between this is a pipe. So this is taking something and moving it into the next argument. Before, when we did this in, this is always going to be, I'm trying to think if it's ever used anywhere but filter. I think it's only used in filter. And it's saying, from this variable, choose these options. So Adelie and Gentoo are in species. You could read it that way. They both have the percentage signs because I think they come from the same package originally. And that just basically, it's a quick way for R to be like, oh, this is a function. This is something special that we're doing. And obviously you don't use percentage signs much in coding. So that was why they did that. So I'm going to give you all 1 minute to, using pipes, subset the penguin data frame to include all species except Adelie and retain the species column in addition to those relating to Bill. So we should have all the species except Adelie, and we should have the species column and all the columns related to their Bill. So I want everyone to try that. I'll give you just like a minute and a half. I like that some people have their cameras so I can tell you're still working. All right, that's a minute and a half. I think some people are done. If you have it, can you paste it in the chat so I can see and we can show the class? From the few cameras that are on, I'm seeing more confused faces, so I might give you all more time. Or just go over it as a group. Okay, great. I got it in a private message, which probably means this person wants to remain anonymous. So I'm going to paste it here. So this person said, from penguins, let's select species and starts with bill. That's a great way to do that. You're using one of the helper functions, super smart. You could have also just said bill length and everything like that. And then species is not Adelie. That's really good. And then I have someone else who pasted it recently. So I'll check that in a second. So let's run this. And it works. We've got species, bill length, and bill depth. And we've got, I assume, Gen2 and whatever the other type of penguin is. I have forgotten. And let's try the next one. I think it's almost identical. Perfect. So both of these would work, whether it starts with or contains bill. The way that the names are structured, both of those will work. So we've got contains the word bill and species, and then we're going to filter based on that. Really great job, guys. If anybody has a question based on those, speak up. Otherwise, we're going to move forward to arranging. So this part is pretty short and sweet. It's basically saying, how do we reorder our data frame? So how do I sort this? Maybe I want to see first the lowest bill lengths and then, sorted until the highest. So it may make sense that we're going to use, I'm just going to base it on one of these. So I can show you that we can extend our pipes and now do an arrange. So if I want to arrange by a certain, this is the same as sort, but it's called arrange. By a certain variable, I can just say bill length. And I'm not sure why it's not auto-completing for me. There's probably a reason, but I'm not sure off the top of my head. So right now, by default, it's going to arrange things in ascending order, meaning smallest to biggest. So we've got bill length. Now we've got the smallest penguin is Gen2, smallest bill length. Chin strap, Gen2, chin strap, and chin strap. If I wanted that in descending order, there's two different ways to do it. So let me copy this and then I'll show you. To make descending order, we can use the minus sign like we did when we were selecting. And so now this would be descending order, or we can say arrange descending bill. The reason I'm showing you both is because this minus sign will only work for continuous variables. If this was categorical and I wanted to sort opposite of alphabetical, I have to use descend. So for instance, if here I wanted to do species, this would work, it would sort it. But if instead I did the minus sign, that's going to give me an error. And this is not a helpful error, but categorical or numeric, anything that's based on character, you have to use the descending thing. So I'm just going to leave that there. So for bill, we can go descending with the minus sign, but for anything that's character based, we have to use descending. And that's about it. I mean, that's how you sort things. That one's short and sweet. That's about all the functions we have, except that we can sort on multiple things in order. So if I want to sort by species and then on bill length, I can then add more than one. So it's first going to sort by species, but then within species, it's going to sort by bill length. Could be useful depending on your purpose. So now I'm going to show you how to add new columns. So select is always either renaming or removing columns. If we want to add a new column, we're going to use mutate. I'm not sure why it's called mutate, but I guess a mutation is something where you're changing something. And so if we want to mutate and add a new column, we can do that using mutate. So here I can take penguins. And by the way, from now on, I'm always going to say data frame pipe and then use the function. I'm never going to say mutate comma penguins. Like I'm not going to do it that way because this is just more aesthetically pleasing to me and more efficient because you can add things on after. So if I want to say penguins mutate, now is where we're going to have a new assignment. So I'm going to say the new name equals old name. So this is just for our own memory. So I'm going to comment that out. And so now I can penguins mutate. I can create something new. So what I want to do is I want to create a variable that is flipper length in centimeters. Flipper length in centimeters. So this isn't a column that currently exists. We only have flipper length in millimeters. I can say flipper length in centimeters is flipper length. There we go. We're finally auto-completing. Flipper length in millimeters divided by 10, because that's how centimeters and millimeters work. For every millimeter, there's 10 millimeters in a centimeter. So I can divide that by 10. And now if I run that, you can see here are our flipper length in millimeters, and here's our flipper length in centimeters. We've now divided this one column by 10 to get a new variable. I don't have to call this something like centimeters. I could call this banana and it would work, but that's terrible practice because you don't know what the heck banana is unless you go back and look at the code. So I think flipper length. Yes, Sydney?
Right, the singular equal sign means like make this thing that, but the double equal sign is like, what is this thing already?
Great explanation. Actually, let me copy and paste wherever I typed that before. I know I typed it. There we go. So a singular is assignment and a double is evaluation. So yes, when it's singular, we're saying make this thing that. And then if there's two of them, that means is this thing this? This is just how I remember it. And you're going to get it wrong plenty of times before you start to actually memorize it. Assignment evaluation sticks in my head after it made sense by making it wrong so many times. So don't feel bad if you get it wrong 20 times. Also, I can now say flipper length in inches. So if I want to do more than one mutation, I put a comma at the end. You don't have to break lines, but usually mutate commands are longer because you're doing multiple things. So I always break the column or break the row so that it goes on to the next line. I'm going to say flipper length inches equals, and I doubt anybody knows how you can get from millimeters to inches. And so I'm going to paste it. So it's flipper length millimeters times 0.0393, blah, blah, blah. So if I run that, you can see we actually go off the screen. I can't see them all. And so I'm going to do a select command now. So if I want to select just things that have flipper length in them, how would I select those columns? So because it goes off the screen, I only want to display flipper length to make sure I'm doing these right and checking my work.
Contain the flipper.
Yeah, perfect. Thank you so much. I think that was Hanwei. Contains flipper length. Perfect. So now I can see here's flipper length in millimeters, in centimeters, and in inches. This is super useful. The practice of mutating is super useful. Maybe making every single length measurement I can think of is not super useful. But maybe I want to make a ratio. So maybe I want to take penguins and create a ratio using mutate of the bill length and depth. So I can take bill ratio is equal to, and then I can use more than one variable here. I can say bill length times, or sorry, divided by bill depth. And now you can see I have a bill ratio of length to depth to see, you know, the width versus the depth. There's a lot of really cool and important things you can do here. So I have another exercise, but I don't want to go through it because we need to move on. I'm going too slow, but we're going thoroughly, so that's good. We'll work on more exercises in the lab on Thursday. So now we're going to talk about aggregation with summarize. Say aggregation with summarize. So aggregation is basically where we take everything and smush it down into one. This is what I said earlier when Raphael, I think, was asking about the difference in geom line and geom smooth. Geom line is saying have a bunch of lines, whereas geom smooth is saying have one line that represents all of them. Well, in this case, we're going to have one row that represents all of the data. So I can say penguins summarize, let me scroll down, And you can do summarize with a Z or an S, whichever works for you, whether you feel British or American for the day. And then I can say mean of body mass. So what summarize is doing is it's expecting a function, whether it's mean, standard deviation, min, max, there's a lot of functions we could use, but saying take all of the data of a column and do that function with it. So in our case, we are taking the mean of the body mass column and then summarizing it. And you can see I got an NA, and that's because if you have NAs in your column, they are going to, if I try to take the mean of something that has missing data, it's not going to know what to do with that. It's going to always give me an NA. So something you will learn very quickly is on mean and other functions, you have to say NARM. Is it RM and A? There we go. NARM. So NA remove equals true. The reason I was questioning that is it was not auto-completing. I doubt myself too much. So now we have the mean of all of the body mass. So originally body mass was here like 3,700, 3,600, 4,600. The mean of all penguins, excluding the missing values, is 4,202. Right here, though, you can see I have this really ugly column name. So as with mutate, I can give a new name. So I can say equals body mass mean. So now instead of mean body mass n equals true, I have body mass mean is 4,202. We can do multiple of these. We could do here, we could get the standard deviation, for instance, which would be something like body mass SD. Again, you can name it whatever you want, but that's most explicative for me. Standard deviation is of body mass G, NA remove equals true. So now I have two new columns, and I only have one row because I've collapsed the entire data set into a mean and a standard deviation. So the standard deviation is 802. The mean is 4,202. One final function here that's pretty helpful is just n parentheses. And what this is doing is saying how many rows were collapsed. So a lot of the time you'll see n equals n parentheses. That's very common practice for people to do, because then I can know there's 344 rows or observations that were collapsed into this mean and standard deviation. If I wanted to instance now know what the mean and standard deviation was for, let's see, Gen 2 penguins, or for all of the penguins, I could say filter here, species equals Gen 2, and then summarize it. So now this is just for the Gen 2 penguins. We can see they're a little bit bigger. But then I would have to rerun this command again for Adelie, and then rerun the command for whatever the third type of penguin is that I've forgotten their name of. So that's like not ideal. What I would rather do is I would rather say, hey, give me these summary statistics for each type of a variable. So what I'm trying to say is I'm introducing a new function called group by. So what I could do instead, let me just run this real quick to show you what it would look like, is say group by, if I can spell right, group by species, and then do this. So let me run that so you can see exactly what I mean. By saying group by, I'm basically taking the whole data frame and splitting it into whatever are the options of a column. So for species, there's 3 options. So it's splitting this data frame kind of into 3. One for Gen 2, one for Chinstrap, that's what it's called, and one for Adelie. And then for each of those, it's going to do these summary functions. So instead of saying species equals Gen 2 and then species, manually doing it like that, this is going to do all of those extra lines of code for us. We're going to split the data frame by species, and then now each species is going to be a row. And we have these same functions of n, body mass, mean, and standard deviation.
Does the order affect like the order of the functions affect in the pipe?
Yes. So if I try to filter after I've not selected a variable, the variable won't be there and it won't be able to select it. So here, if I did a group by after I summarized, actually, let's try it. And we can say group by species. First of all, there's no species column because when I run this, we only have 3 columns: body mass mean, body mass standard deviation, and n. There's no species column for it to group by. And we haven't grouped by anything. And so there's 1 row per total for the entire data set. So group by summarize, like that phrase, group by summarize, is very commonly used. And this is actually a lot of what data science is group by and summarizing in interesting ways. So you could group by year and see how different languages vary across, I don't know, churn in a business. That's a lot of what data science is. And it's actually really fun to use these in puzzles and figure things out. We'll continue to learn other functions that will help us do that. But basically, this is called split, apply, combine data analysis. So you're splitting the data set, you're applying a function, and then you're combining it back together so you can read it. So I could do the same thing by island instead. So I could say penguins group by island, or I could say island and gender, sorry, sex. Island and sex, and then let's say summarize. Let's do just something quick. I'll just copy this part. So now if I split by island and sex and get the mean, you'll see I have more rows because I've got female on Bisco, male on Bisco, and then NA gender on Bisco, female on Dream, male on Dream, etc. So you can group by in very interesting ways, and you can group by multiple categories. So because there's technically 3 genders in the sex and 3 islands, you'll get 9 rows total doing the same aggregation function over everything. You can make these very complicated. You can do means, mins, maxes, etc. You can do very difficultly, you can do regression in this context too. It's not that difficult, but don't try it yet. And then one final thing I want to cover in the next 4 minutes, which is I think is plenty of time, is how to get just this n. So something very common we might want to do, and I previewed this way earlier to get the types of categories, is how many do we have in each category? So if I just want to know how many females there are in my data set, let me actually add a header here. I could say penguins and then count sex. And this will give me the total count for the entire data set. Let me answer Mal's question in a second. So for this entire data set, I could get everything disaggregated by this one column. So we've got male, female, and NA here. This is quite similar to what we just did here with group by and summarize. I could do the same thing with a lot more lines of code by saying penguins group by sex and then summarize n equals n. It's going to give me the exact same output, just a lot more lines of code. So you can see those are the exact same. Really good question, Jinru, and great question, Mal. So for Mal, if I want to create a new table, what I can actually do is I can just say, let's say here, because this is more extensive, body mass stats, and then save this. And now I have a new table called body mass stats that I can work off of. I can even pipe this then into ggplot and do plotting with it. So the difference between n parentheses and count is that n parentheses is used within summarize, or actually you can use it within mutate too, I think. That will be within a function. It's like a helper function, whereas count is using n parentheses and just doing everything for you. So basically this entire lines of code are contained within count, and count is just like doing it quicker. So I could do penguins, let's say count species island. So now this will tell me how many observations, so how many rows are of each species on each island. So it starts with, I think, on a 9-row data frame of each species in each island. So that would be like chinstrap on Torgeson and Adelie on Torgeson. Like it would have all of those, but then it realizes kind of quickly, we only have 5 rows here because there are 0 chinstrap penguins on Torgeson. There are 0 Gen 2 penguins on Torgeson, and it automatically eliminates those rows and just leaves us with the actual combinations that exist. There's a way to fix that, but I'm not going to get into that today if you want those zeros. But this is extremely useful. Let me think if there's anything else we want to cover here. I mean, you can disaggregate even further by adding sex, and then you have each species on each island with each sex and how many ends are in each row. You can then plot these like I mentioned. So if I wanted to, this probably isn't the best example, but if I wanted to plot this into ggplot, I could pipe into ggplot. Jinru, such a hard question. Okay, so this way here, so Jinru is asking about this funny pipe. This is the normal pipe. There is another pipe that's facing the opposite way, and I believe there's a pipe that you can use to save things. I actually don't remember what this one means. I think I can search for it like this. I mean, in short, you're probably not going to use it. It is a type of assignment pipe from the Magritter. I never remember how people say that, Magritter package. Yeah, so it is an assignment pipe. I think you would do that at the end to say a new save, I think. No, it didn't like that. Something like that. Yeah. There's a lot of things that like some people use a lot in their workflow and then others that are just not common. And that's one that's just not common. Okay, so if I wanted to pipe this into ggplot, I don't have to write penguins. Class is over, so I'm gonna do this really quickly. I can just skip straight to AES and say X equals, let's say, island, Y equals N, and then let's say fill by species. I'm gonna take out sex there, but I still have to use a plus sign here. So that's something to remember is you're piping, but then when you get to ggplot, you have to start using plus signs. What is it giving me there? And then geom, let's say geom bar and geom call. And then here's where you could do all of your ggplotting. But so here's where you would manually be aggregating, disaggregating. You have a lot more control of your data, and instead of just letting ggplot do it behind the scenes for you. Okay, so I will see everyone on Thursday for the lab where we're going to go through all of this as in groups. I don't know. This is a part of R that I just find so fun. I don't know if you can tell, but all of these functions are so useful, and you can, I mean, there's so many functions I didn't teach you as well that you can use in really interesting and important ways to get your data how you want it, to work with it, to have interesting insights into what's going on in your data. So we will work on that on Thursday. You won't have a homework for like 2 or 3 weeks, so you don't have to worry about that. You just have to worry about the lab. There is a reading, and the reading is basically to go through the chapter in the book about everything we talked about today, and you'll learn some of the other functions I didn't cover there. I think like slice, and I don't know, there's some others you'll learn about. So I'll see you all on Thursday.
Thank you.
Thank you.
Thanks, everyone.